compare which one has a larger order of growth compared to the other one. Okay, so as a simple way, so you can apply limit n tends to infinity t of n divided by g of n. So it is nothing but it is 1 by 2 n into n minus 1 divided by n square. Okay, so n will get cancelled. So you have 1 by 2 constant, and then here you are dividing the numerator by n. So you will have 1 minus 1 by n. Is a simple now. So you need not always apply the derivative. If you cannot apply the limit directly, then you can go for the derivations. Otherwise, you need not apply the derivations always. Okay. Now, as the limit n tends to infinity, what will be the value you are going to get? What will be the value you are going to get as n tends to infinity?
1 by 2.
So it is 1 by 2. Within a bracket, it becomes 1 minus 0. It is 1. So it is a constant. A constant which is greater than 0. Okay. Indicating what? As per our procedure. Indicating what? C, a constant greater than 0 indicates both t of n as a same order of growth as g of n. That means both of them are having same order of growth. You can just observe here also, when you multiply the left hand side function t of n also, you will get some n square minus n. Another one is also having n square. So both of them are having the same order of growth. Okay, so it's a simple example. Now we'll take another example. So we'll take t of n equal to log n base 2 and g of n, it is square root of n. Okay, now we'll compare limit n tends to infinity t of n divided by g of n. That is nothing but limit n tends to infinity, it is log n base 2 divided by square root of n. Okay, so log n base 2 divided by square root of n. Now see, the log n base 2 can be written as, see, limit will continue. Okay, I don't write it repeatedly. Log n base 2 can be written with base e. Log n base e divided by log 2 base e. I think you know the mathematics. Okay, from that you can write base 2 can be converted to base e in this way. So is a log n base e divided by log 2 base e. Okay, then we can take square root of n as it is. Okay, now further, see, in the numerator you have 1 divided by log 2. So I'll take out separately. It's 1 divided by log 2 base e, and then I will keep log n base e divided by square root of n. Okay, 1 divided by log 2 base e take out separately. Okay, limit n tends to infinity will be there, that till we apply. Okay, then this 1 divided by log 2 base e can be written as again log e base 2. 1 divided by log 2 base e can be written as log e base 2. Okay, and that into log n base e divided by square root of n. Okay, have you understood these steps? Just applying the mathematics, the standard formula. Log n base 2 converted into base e, okay, and then 1 divided by log 2 base e written as log e base 2. Okay, that's all. Okay, now we'll continue that. Now, so log e base 2, okay, will be there separately. Then we'll apply limit n tends to infinity log n base e divided by square root of n. So limit we are applying to now, because log e base 2 it's a constant, so we just take it out separately because e value is a 3.7 something. Okay, so that is going to be a constant, that's why take out separately, and we are applying the limit n tends to infinity log n base e divided by the square root of n. So by using a L'Hospital's rules, now I told you can obtain the derivations of this and then you can apply limit n tends to infinity log e base 2. Now, what is the derivation of log n? What is the derivation of log n with base e? We are just applying the derivation, that's all. What is the derivation of log n?
1 by n.
It is 1 by n divided by, what is the derivative of square root of n? What is the derivative of square root of n? It's a 1 divided by 2 into square root of n. That's all. Simplified. So it is log e base 2. So it is 1 by n can be written as square root of n into square root of n. Then 1 by 2 square root of n can be written as 2 square root of n divided by 1. Okay, 1 square root of n will get cancelled. Then you have 2 into log e base 2 divided by, and limit n tends to infinity. It's a 1 by square root of.
Sir, after log e not visible, sir.
After
log e by 2.
Log e by 2.
Base 2, sir.
Log e base 2. Okay. So now, is it visible till now?
Sir, after log e base 2 in right side, that is also not visible, sir.
Now, is it visible?
Yes, sir.
Now you just simplify it. You for log e base 2 into limit n tends to infinity 1 divided by n divided by 1 by 2 square root of n. Okay. So I will write here log e base 2 limit n tends to infinity. Okay, or else I will write in the numerator. Okay. So log e base 2 limit n tends to infinity. I just simplify this. It is 1 by n can be written as square root of n into square root of n. No? 1 by n. Yes or no? 1 by n written as n can be written as square root of n into square root of n. Then in the denominator you have 1 by 2 square root of n. So we will write 2 into square root of n divided by 1. Understood? It's just simplifying, that's all. A by b divided by c by d. Okay. So square root of n will get cancelled. So we have log e base 2 limit n tends to infinity, and this 2 is also a constant, then 1 by square root of n. So you have 1 by square root of n. As n tends to infinity, it becomes what? It becomes what? As n tends to infinity, 1 by square root of n. As n tends to infinity, this becomes 0, no? For a large values of n. As n tends to infinity, this becomes 0. So when it becomes 0, then which one is having a smaller order of growth? Your t of n has a smaller order of growth compared to the g of n. That means your log n has a smaller order of growth compared to the n factorial. Compared to the square root of n. So log n has a smaller order of growth compared to square root of n. That's all. Okay. Now we'll see another simple example.